All right, I'm going to go over two examples of solving equations. These ones are a little bit trickier because the distributive property is applied, but we've got some negative numbers. So that's at least for this first example. 50 equals negative 5 groups of 6n plus 8. So my first step, I'm going to apply the distributive property. This negative 5 times 6n and this negative 5 times 8. I'm going to distribute that negative 5 to both of those terms. The solution is going to be 50, no change on the left side, equals negative 30n plus negative 5 times 8, that's negative 40. Okay. Now, I got one variable, n, negative 30n. I need to figure out how to get that variable isolated all by himself. So one thing that I can do is I can add 40 to both sides. I'm going to create a zero pair by adding 40 to both sides. What I do to one side, I've got to do to the other. By doing that, on the left side, 50 plus 40 is 90, equals, I didn't do anything to negative 30n. It still remains negative 30n. But negative 40 and positive 40, that's a zero pair, so that's gone. Okay? So now I have 90 equals negative 30n. I want to know how much 1n equals. So I'm going to divide by negative 30. Right, to create a giant 1, I created this giant 1 right here, negative 30 divided by negative 30. But what I do to one side, I got to do to the other, negative 30. I divided both sides by negative 30. That leaves me with n on the right side and negative 3 on the left side. 90 divided by negative 30 is negative 3. And now I can check my work. I just need to substitute this answer, negative 3, in for n. So let's do that onto the side. So I have 50 equals negative 5, 6 times n. We said n equals negative 3, okay, plus 8. All I did was substitute this n value, negative 3, for n in the original equation. 50 equals, I do what's in the parentheses first, so I have negative 18 plus 8. Again, I'm still working within the parentheses first. Negative 18 plus 8 is negative 10. 50 equals negative 5 times negative 10. When I multiply two negatives together, it becomes positive. 50 equals 50, so we know this is good. The equation is true, check, check. I know that n equals negative 3. Okay, I said I'd give you one more example. Let's go through this one. Negative 6n minus 2n equals 16. If the negatives trip you up, let's change subtraction into addition. We can make this, rewrite this as negative 6n plus negative 2n, right? We learned that way back in chapter 2. We can turn any subtraction problem back into addition. So I have a lot more negatives than I had before, negative 6n, right? I've got negative 6n plus negative 2n, that's negative 8n equals 16. Now we can solve this. I want to know what 1n equals. 1n. So to do that, I'm going to create a giant 1. To get rid of this negative 8, I'm going to divide by negative 8. What I do to one side, I got to do to the other. Divide the other side by negative 8. Why did I do that? Created a giant 1 here. Negative 8 divided by negative 8. That leaves me with n on the left side equals negative 2. I can check my work. I substitute the value of n back into my original equation. Negative 6 times negative 2 minus 2 times negative 2 should equal 16 if I have the right solution for n. I multiply two negatives together. Negative 6 times negative 2, that's 12. Let's add these two together to make it easier to understand. Adding negative 2 times negative 2. Okay, I just rewrote it, subtraction as addition, to make it easier to understand. 12 plus negative 2 times negative 2 is 4 equals 16. And in fact, 16 equals 16. I'm good. Check, check. This is a true equation. 16 equals 16, so I know n equals negative 2.